Welcome to today's video, where we'll be diving deep into a fascinating problem surrounding Boost Asio. Have you ever wondered how a function like async_read_ some can magically turn into a callback? Well, you're in the right place because we're about to unravel this mystery together. Now, let's talk about the solution to our problem. The key lies in the use of yield_context and stackful coroutines in Boost context. By employing stackful coroutines, each coroutine gets its own separate stack, which is preserved across suspend resume cycles. This implementation allows for the creation of callbacks that can be registered and executed when the data is ready to be processed. Continuing with our exploration of the solution, let's take a closer look at the code snippet provided. By utilizing Boost context fiber, the spawn_fiber_thread class serves as the backbone for implementing stackful coroutines in Boost Asio. This class, along with Boost context fiber mechanisms, enables the seamless execution of asynchronous operations and callbacks within the Boost Asio framework. In summary, we've uncovered how Boost Asio leverages stackful coroutines and Boost context to transform regular functions into powerful callbacks. It's truly fascinating to see how these underlying mechanisms work together to enable efficient and concurrent programming paradigms. We hope you found this exploration as enlightening as we did. And with that, we've reached the end of today's video. If you enjoyed this content, don't forget to subscribe, like the video, and share your thoughts in the comments below. Until next time, happy coding,